Hi everyone, here is the next instalment in the Homework Help series. So we have a question from the Chapter 5 review. Here it is, 3 coloured blocks are taken at random from a pile of blocks with 6 red, 4 green and 3 blue ones. What is the probability that 2 will be green and 1 will be red? So let's consider our sample space first of all. So we have 6 red, I'm not going to write 6 R's in a row, 4 green ones and 3 blue ones. Lovely. Now we're choosing 3 blocks at random, 3 coloured blocks. So first let's work out the number of ways that this could occur. How many ways could we select 3 blocks from this group? Well, altogether there are 13 blocks there. So in this particular experiment, the number of ways of choosing is 13C3. Now, I know that it looks like there are 13 objects in the sample space. That's really just the set of blocks we're playing with. Perhaps it was a mistake to write S here. This is the set of blocks. The experiment is to choose 3 of them. If I was writing the sample space, then the sample space would be combinations of 3 blocks, and there's going to be a lot more than 13 of those. It's 13C3. So using our rule, we have 13 factorial over 13 take 3 is 10 factorial by 3 factorial. Remember, this would simplify down to 13 by 12 by 11 over 3 by 2 by 1. When we cancelled off the 10 factorial that was at the end there. And now what does that come to? Well, 2 times 3 is 6, goes into this twice. 2 times 13 is 26. 26 by 11, 26 by 11 would be 286. That's how many things there would be in the sample space. It was a mistake of me to say that this was the sample space at the beginning. This is not the sample space. This is just the objects that we are dealing with. The sample space, which I'm not going to write out completely, now that I think more carefully about it, would be groups of 3 blocks. Maybe I would get 3 red blocks when I grabbed 3 at random. Maybe I would get 2 red blocks followed by a green block, and so on and so on. If I wrote down every possible grouping of 3 blocks, that's my sample space, and there would be 286 things in that list. I could use a tree diagram to figure them out. It would be a horrendous tree diagram. I'm not even going to attempt to draw that. This is why we have the idea of combinations, so we can get the answer accurately and quickly. Now let's start thinking about the event we're interested in. So the event that we're interested in, how many ways are there of the event said 2 will be green and 1 red? So 2 green ones and 1 red one. Well, to select 2 green blocks, it's really choosing 2 out of a subset of 4. So there are 4C2 ways in which I could pick the 2 green blocks. Remember, the word and translates to multiplication, and the red blocks, there are 6 of them and I'm choosing 1. So how many ways could that happen? Well, 6C1. Now let's work these ones out. 4 factorial over 4 take 2 is 2 factorial by 2 factorial. 6 factorial, 6 take 1 is 5 factorial by 1 factorial. Now that would be 4 by 3 over 2 by 1, and this would be 6 over 1. That's straightforward. What are we going to do with this? Let's cancel that 2 into this 4 and leave a 2 there. So we have 2 3s, a 6 by 6 is 36. There are 36 ways in which the event could occur. The sample space, there are 286 possible ways of collecting 3 different blocks. Only 36 are favourable. We can do the probability now. The probability of getting, what was it, 2 green and 1 red, 2 green and 1 red. That's my event. Remember, it's the number of ways that the event can happen, 2 green and 1 red, divided by the total number of events in the sample space. Favourable over possibles. 36 we worked out, and the sample space contains 286. Now when I plugged that into my calculator, I got 12.6%. There we go. So a lovely little question involving probabilities using combinations to calculate the answer. Thanks for watching. See you next time.